Okay, so now we have a little variation here. Last time we had to write the standard form when we're given some sort of an equation. Now we are given some points. So we have three different possible ways of doing it. Here, let's do it this way. First of all, we have a vertex. Vertex is given as on the x-coordinate, see? Some x and the y is 0. So this is going to have a horizontal major axis. In fact, let me just start plotting those things. Here, let's say -4 and 0. So here we go. So in this case, 1, 2, 3, 4. 1, 2, 3, 4. Here's a vertex at -4 and 0. That means on the opposite side, this is assuming again that the midpoint between the two foci or the two vertices, okay, is at the origin. Okay, so when they give you one side, we just know that on the other side is exactly the same thing, symmetrical. So there it is. There are the two vertices. And the vertex is always given as the A value. The co-vertex is given as a B. See, the x is 0 and the y is 3. 1, 2, 3. So that's a 0 and 3. That means on the opposite side of the origin, 1, 2, 3, is the other part of the co-vertex, so which is 0 and -3. So I could already sketch the ellipse to look something like this, I guess, huh? There it is. Now we have to know where the focus is. Where is the focus? The focus is, we use the formula again, c squared is equal to a squared minus b squared. And since we already know what a and b is, we just substitute it and square root it. So c is equal to square root of, well, let's see. The a is -4, square root is 16. Minus b is 3, squared is 9. So 16 minus 9 is 5. So that's a square root of 5. Okay, what actually is a square root of 5 approximately? So we're going to use a calculator and determine that, make it faster. Square root of 5 is approximately 2.24. 2.24. Okay? Wait a minute. 16 minus 9 is not 5. I'm sorry. 16 minus 9 is 7. That number looked kind of weird. Okay? So let's try that one more time. So then square root of 7. Here we go. Almost got in trouble there, huh? Yeah. Square root of 7 is about 2.65. Whoop-de-doo, but it is a different. So approximately 2.65. 2.65. So 1, 2, point half. Then a little beyond that is 2.65. 2 point and a half. Beyond that is 2.65. So now how do you write the equation? Since it's in horizontal major axes, we write a standard form of x squared over a squared plus y squared over b squared is equal to 1. Okay? And once again, a is 4 and b is 3 and c, we just almost made a mistake, but it is square root of 7. Okay? We don't need a c for our equation, but we could write that as x squared over a squared is 4 squared, or simply 16, plus y squared, b squared is 3 squared, which is 9, equals 1. And that is a standard form, an evaluated form. Okay? Now, number 2 and 3. If you dare, you could pause this video and try it on your own. Oh, otherwise, I could start checking it, okay? So this time, vertex. Again, the vertex is the A. A is 8 on either side of the axis. Okay, the focus is the C, which is in this case, -4 square root of 3. Now, B is what we do not know. So, to find the B, we're going to use the same formula, C squared is equal to A squared minus B squared. We're going to solve for B. So we're going to bring this B over to on this side, so it becomes B positive. And then we're going to move the C over on that side. Okay, so B is equal to square root of A squared minus C squared. A is given as 8, so square is 64. C is given as a radical, so let's do that over here. -4 square root of 3, that's a C. And if I take a square root of that, the rules of exponent says -4 times -4, 16 times the radicand comes out, So it's 48. And 64 minus 48 is 16. This time I'm sure, I think. And square root of 16 simplifies to become a 4. So the C is 4. Okay? Oh, I mean the B is 4. There we go. Whew. Almost going to the wrong place again. And now check this out. Okay, so the vertex is given on the y-axis. So this is going to have a horizontal major axis. So we better draw our ellipse to match something like that. And the coordinate is 0 and 8. I'm going to go by 2's, so go a little faster. 2, 4, 6, 8. So the coordinate for that vertex is 0 and 8. That means on the opposite side, 2, 4, 6, 8 is its own corresponding vertex. Okay, now we just determined that the B is now 4. So that's the co-vertex, 2, 4. So 4 and 0 on the opposite side is true. Negative 4 and 0. And what are the foci? That's going to be negative 4 square root of 3. And what approximately is negative 4 square root of 3? Let's see. 4 times the square root of, what did we say? 3. When you get old, things just go away from your mind real quick. 6.9 approximately. So 6.9. So since we have a vertical major axis, the foci will be on that same axis, 6.9. 2, 4, 6. Here's a 7. Then 6.99 must be somewhere over there. 2, 4, 6, 7. So 6.9 must be somewhere over there. And now I could draw my ellipse. Looks like a football, getting ready to be kicked. Okay, and how do you write the equation? Standard form. It is x squared. This time, since it's along the y-axis, the b squared must come under the x, plus y squared over a squared equals 1. That's the one we're going to use now. So when we substitute all the numbers, x squared over b, we found it to be 4 squared, which is 16. Plus y squared over a was given as 8. Squared is 64 is equal to 1. And there's my standard form. And this one? Alright. Now this time co-vertex is given again on the x-axis. You see that? X, y. Since it's given on the x-axis, again we're going to have another vertical. We're going to have another vertical major axis. Okay? Co-vertex is given as b. The focus is the C. So it matches the vertex. It's a vertical major axis. So the focus is along that axis as well. So we have a C and a B. How do we find the A? Well, again, C squared is equal to A squared minus B squared. This time, we're going to solve for A. So let's keep that A and just move that B over. And when we use the identity, it should be A is equal to square root of C squared plus B squared. Let's substitute in the C and the B. C was given as 9. So that's 81. Right? Okay. And B is given as 2 square root of 10. So let's do that calculation here. 2 square root of 10. The rules of exponents says 2 squared, which is 4, times the radicand comes out as 10. That's 40. Right? There. And we're going to take a square root of that sum. And 81 plus 40 is 121. And 121 square root it is, ta-da, 11. And that's a C. Oh, that's an A. That's an A. Okay, so we have our A, B, and C. And now let me go and draw the picture. Okay, I like pictures. Once again, it's going to be a vertical major axis. Okay, so the A is 11, 5, 10, boom, 11, 5, 10, boom, 11. Okay, and the co-vertices is given as negative 2 square root of 10. What is a negative 2 square root of 10? Let's do that approximation. 2 times the square root of 10. Okay, and that comes out to be approximately 6.3. So 5, somewhere there. 5, somewhere there. So that is negative 2. Oh, that's a positive square root of 2 square. Yeah. 0. Almost there. Negative 2 square root of 10 and 0. Okay, so there is our ellipse. And finally the focus, okay, the vertex was 11. The focus is on 9 right there. How do you write the equation? Once again, it's a vertical major axis, so we need the B to be under the X. And we're going to substitute the B and the A. And so the B is given as that. And what did we just say that was? Let's see. When we square, I just did it somewhere here. Oh, there it is. Okay, that's a 40. Okay, so 40 goes over there. Okay, and the y squared over A we determined to be 11, so it's 121. So that'd be 121 equals 1. I just realized when I checked the camera, many of you cannot probably see the right portion of this paper, so let me move it a little bit. There we go. Yeah, you didn't really miss much. There we go, a little bit more.